Hello, friends. Now, you have seen in my previous video that a cantilever sheet pile is embedded into a granular soil bed and how to draw the pressure distribution that you have seen. And based on the pressure distribution, you are in a position to calculate the maximum bending moment, shear force, etc. etc. The pressure distribution and depth of embedment also you could calculate. So cantilever sheet pile having a backfill of granular nature. Also you have seen that below the dredge line, the bed was granular in nature. But in this case, let's say the cantilever sheet pile. And the ground is going to be cohesive. So phi in undrained condition is going to be 0. So it is purely cohesive soil. And the backfill is going to be granular. So this is having C equal to 0, phi is greater than 0. So this is a granular backfill. And this is the dredge line. This is the top point A, and let's say the bottommost point is B, and dredge line, this is D. How will you draw the pressure distribution diagram? This is cohesive in nature. Is below this ground, it is cohesive ground bed, cohesive soil bed, or this cohesive ground or cohesive bed. Now here, if the total unit weight of the backfill material is gamma, and the height of the cantilever sheet pile is H. So cantilever sheet pile embedded in cohesive bed. So embedded in cohesive bed. This is the kind of scenario. How will you draw the pressure distribution diagram? Here, at this point, the value of phi u is 0. So if phi u equal to 0, then naturally the coefficient of passive earth pressure and coefficient of active earth pressure becomes 1. Both becomes 1. Now, for this, the pressure distribution is going to be linear because it is granular in nature, you have seen. So triangular pressure distribution or hydrostatic pressure distribution is going to be like this. And the total pressure at this point, vertical pressure, is going to be this gamma into H. So, how this is going to rotate? My cantilever sheet pi, which is embedded in cohesive bed, is going to rotate, or the deflection pattern is going to be something like this. It is going to be like this, about 0.0. So in this zone, below the dredge line, here it is going to be passive, and this side it is going to be active. Below O, it is going to be passive, and this side it is going to be active. Let's say this is left, this is going to be right side. So on the right hand side of the sheet pile, and this is our cantilever sheet pile, right? So based on the deflected pattern, here we know that the vertical pressure is going to be, so what will be the active pressure? So active pressure at D, at the dredge line. So at dredge line, that is at D, I can find out the value of active earth pressure, which is going to develop on the right hand side. So at the dredge line, that is at D, on the right hand side, the active pressure will be given by the vertical pressure multiplied by K minus 2 times cohesion under root K. Now, what is the value of vertical pressure here is gamma H. So this will be gamma H, K is going to be 1 minus 2C. So on this side, the active component on the dredge line gives you this value. Similarly, you can find out the passive earth pressure. So let's compute at the dredge line, the passive earth pressure should also be computed. So at the dredge line, that is at D, the passive pressure which is developing on the left hand side will be given as sigma V Kp plus 2C under root Kp. Now Kp is 1. So this becomes sigma V plus 2C. Now on this side, on the left hand side, the passive earth pressure is going to develop. So at dredge line, what is the vertical pressure? There is no vertical pressure, it is 0 plus 2C. So this becomes 2C. Therefore, the difference between passive and active earth pressure can be calculated. So therefore, the passive pressure minus active pressure at dredge line can be computed, and this will be 2C minus gamma H plus 2C. So it becomes 4C minus gamma h. So friends, the pressure here at the dredge line is given by 4C minus gamma h. Let's say this is the pressure here. This is 4C minus gamma h. Now, at the bottommost point, if you go, you find that it is going to be active, just reverse, diagonally opposite, and passive below, it is going to be passive. So at B, so this pressure is going to change. It become passive. So it was like this. So this pressure is going to be 4C minus gamma h. And this pressure we need to calculate. So let's calculate. So at B, let us calculate. Let us calculate at B. So at the bottommost point at B, what will be the active pressure on the left hand side? That you can calculate it. So PA, which is going to be on the left hand side, you can calculate it. What is the equation? You know it. Sigma V into K. K is 1. So sigma V minus 2C under root K. K is 1. Therefore, this becomes the equation. Now, what is the vertical pressure at this point? At B. At B, it is going to be here. What is the unit weight? Unit weight is gamma. And what is the distance from the dredge line up to the bottommost point? It is capital D. So vertical pressure sigma V becomes gamma D minus 2C. I hope there is no confusion here. Now PP, which is on the right hand side. So PP gets developed on the right hand side at B will be given by sigma V into Kp. Kp is 1 plus 2C under root Kp. So it becomes like this. Now, on the right hand side, friends, the vertical pressure at B is going to be gamma times H plus D. So at here, on this side, it is H plus D. That is the vertical pressure plus 2 times cohesion. Therefore, the net pressure here will be PP minus PA at D can be calculated. So it becomes gamma H plus D plus 2C minus gamma D plus 2C. I hope this is quite clear. So this gamma D and this gamma D will get cancelled. So finally what you get it is 2C and 2C becomes 4C. So this pressure becomes 4C plus gamma H. So here the pressure becomes 4C plus gamma h. So the pressure distribution is easily found out. So there is no difficulty at all in drawing the pressure distribution. Very easily we can do it. And if you want to equate sigma, let's say this is h, this height may be called as h1 or whatever you want to keep it. If you want to keep it something else, you can keep it like that. Or let's say this height is h1. So from here up to here, this height is h2 up to the bottom. So h1, h2. Now, for equilibrium condition, you can always calculate sigma fh. The algebraic sum of all the horizontal forces must be equal to 0. Let's say the resultant of this active pressure is PA, which is acting at a distance y bar. So you can you can always find out the area of the pressure distribution diagram between A and D, and that would give you the magnitude of PA. And you can always find out the value of its location, that is y bar. Now, if you equate sigma fh equal to 0, that means if I call this A, D, this point as B, this point as E, this point as F, this point as capital D, this point as D1, this point as capital B. Then sigma fs equal to 0 means the value PA, right? That is the area of this complete minus is acting this way. So area of if this is B, this may be called B1. So minus area of DD B1B is going to act this way, plus is going to act this way. So plus area of pressure distribution diagram FB, F, this is F, this point. So F, B, B1. So F, B, B1. So you can easily find out the area, this area. This area is already known to you, and therefore you can equate it to 0. And this will give you the value of H2. So H2 can be very, therefore you can, from this you can get the value of H2. So Pa, let's say this is 1. So this becomes so friends, how simple it is. Pa minus what is the area? So this you know it, half. No, this is going to be a rectangular. So 4c minus gamma h. 4c minus gamma h into d plus what is the area of FBB1? That is half 4c plus gamma h, and this is going to be plus 4c minus gamma h. That becomes half BB1. So half BB1, this goes out into this height H2 must be equal to 0 for equilibrium condition. And therefore, Pa is known to be, and therefore H2 will be in terms of D. Right? Now takes moment. So H2 you can easily find it out in terms of D. So once you get H2, which is a function of D, right, in terms of D. Therefore, now for equilibrium condition, you know that algebraic sum of moment about the bottommost, about the base must be equal to 0. Now, you already know the magnitude of Pa. If this is y bar, this becomes the moment will be y bar plus D. So due to this, you know it. Now, you can always find out the forces here, and forces this one, and their point of application, you can find it out. Already the force is known to you, so you can always find out the force. So minus this force, which will be acting at d by 2. So this becomes 4c minus gamma h into d square by 2 plus this force is now already known to you, and H2 in terms of D. So plus this force, and the magnitude will be acting at D by H2 by 3. So this force multiplied by H2 by 3. And H2 is already known in terms of D, must be equal to 0. So by solving this equation, you can find out the value of D. Therefore, D is computed. This computed value of D should be increased by 30%. Therefore, D provided will be 1.3 times D. This is for factor of safety equal to unity. So you should increase the factor of safety, and 1.3 times D will be the value of D provided. So friends, today this part also, if it is a cohesive bed, how simple it is, you have seen it, and how to calculate I have shown you. In the next video, I will take a problem, example, and then we would like to solve this. So please keep on putting up your doubts. I have already created the channel so that I can reply you appropriately. Thank you very much.